Hello. Today we're going to be working on something new, hopefully something interesting and fun. We're going to be building LINQ for Unity. I don't know the best way to describe this tool exactly, but the goal is that you can, hello. The goal is that you can write queries against your current scene or against Unity and run those queries. So, my hope is that you can just write normal C# code. So any of the functions that you have available to you in your normal code, you can write into this console up here and just do like game objects find with name. We'd find the main camera, and we'd want to select the transform of that, and maybe get just the position of that. And then from this, we'd get one of these nice editors down here. And you'd be able to both see all of the results of everything that matched your search criteria. So maybe you want to find all the lights in your scene and be able to see all of the lights configured in your scene, or all the physics objects or rigid bodies or whatever. This would give you a way to sort of query those and edit them. And then you'd be able to do all the normal stuff. And then it gives you fancy renders that are sort of configured for each of the types. I have three implemented right now. One is for just strings, one is for integers, and one is for vector 3s. And I believe one is for color as well. And this sort of allows you to do fast, quick editing in sort of a controlled query without having to go and find all the objects here or do a search up here. Unity does provide a way to do searches, but it's sort of a search syntax and not a code syntax. And so a big point of this is you should be able to write code just like you would normally do and find all of this stuff. I've been running into issues. That's what we're going to be getting into with actually doing this. It turns out that this actually doesn't really work that well. Part of the problem is this position right here. There are two types of, I guess, variables in Unity or in C# really. There are value types and there are reference types. And so if you use a struct or you use like a basic type like an integer or a float, those are value types, which means that anytime you assign to them, you're not creating you're creating a copy of whatever it is. So if you actually had a demo here. Let's see if we can find it. Here we go. All right. Not exactly prepared, but this should demonstrate it. This is my experiment. Typically, if we have a thing, so if I do, just remove all this reference stuff. Let's just drop it for now. So all of the references are removed here. So we have two variables. We have int x, which is equal to 42, and we have int I, which is set to the returned result of this test function, which is just x, and then we assign that to 1337, so just leet, and then we print out the value of x, and so what we would expect here is that the value of x should be 42 because it's a copy. Anytime you change a value type, it's going to change that value alone because otherwise it would just copy it. It has no way to get back to all the previous references. The downside of this is things like vector 3s and colors are all structs in Unity. And so if you select all of the positions in your scene, you're just going to get read-only data. And so the problem with that is that if you want to change it all, so you want to move everything up by 1, for example, it's read-only, so you can't actually do that. There's no way to go back and say I want to move this or I want to change this value because it's read-only. I got around this by adding this read-only thing here. It makes it visible, but it's not great. So what I want to do is find some way to accomplish this. C# does give you a way to get around this, and that's using the ref keyword. So if we do ref here and make all of these references, and I believe this needs to be a ref too. And so what this does is it's saying we are returning a reference to this value. And so we're no longer returning 42 when we call this function. We're actually returning the reference to the register or the place storing 42. And so when we run this, I didn't run the original one, so bad example. But this should actually return 1337. And it does. So instead of assigning to I, we're actually assigning I to point back to that reference. Let's just undo all these ref keywords and run this again, and we should see 42 because this is now a value type. So the problem with this is twofold. Everything in Unity is sort of a struct. This is done to sort of keep everything as data objects. Some people tell you that structs are faster than classes. I think that's sort of a side effect more than any actual gains. I'm not entirely sure on that, but structs and classes are stored in two different places. One goes on the stack, one goes on the heap. That's more of an implementation detail again, but they are treated differently. So, problem we run into is this isn't how Unity works. I thought this was going to solve all my problems. Just use ref, and it will just work. Problem is, this again isn't how Unity works. Unity does this, and this doesn't work anymore. They use properties for their fields, and so because of this, we can't actually get the reference out of that property because the property doesn't actually return that. We would actually need to go in and change this, I believe, to do something else. The property would need to be implemented entirely differently. And we can't change Unity's code, so this doesn't work. What I'm hoping to do is figure out how to solve this. And all of the things that I've thought of to solve this involve not doing any of the things that I thought I was going to be able to do. There's really two. One is to implement a custom language, like a custom query language, something like SQL-like or something else that allows you to query in that way. And then we can write a parser and handle it all ourselves, and everything is fine. The other option, what was the other option? There was some other option to do reflection things. If you're unfamiliar, we're going to stick in this project, I guess, for now, because this is way easier than what I have in Unity. Unity is confusing. What this would let us to do is say get x.getType, get property like this. We want to get the property. That's not how that's going to work. Generic aliases.getType. I don't think this works anymore. But basically you can get the type of things. We'll do this or not. x.getType.getProperty of something, and then from that property, we'll just end here var prop. You can do things like set value to invoke the property setter, or prop.getValue to get the value. And this, I think, would work. If we could return this property, it should be fine. The downside is there's no actual easy way to do this. As far as I can tell, this is not an easy thing to do. Because like that code that I originally wrote, let's go to Unity so we'll actually get something. Ignore. This code is gross. But we want to do something like game object dot find game objects with tag, for example. And we'll just go foo. We don't actually care what the result of this is because we're not actually going to be doing this. But the idea is you would be able to do write something like this and then do dot Git component. Does that actually? Oh yeah, it does. Because so this is a custom function that I added. It actually, given a list of game objects, it gets you the components attached to each of those game objects. So it's effectively a select, but this is a wrapper to make that select a little bit more fluent. Let's say we just want to get all the transforms from all of those game objects, and then select the position. So this is sort of the idea behind all of this. This is sort of what I wanted to be able to do. So you could get the transform, get the position, and then you just have an easily editable set of positions. The issue is if you write this t.position is going to return that value. It's going to return you whatever the position of that object is, and that's not what we want. Instead of this t.position, we actually want, I don't even know, property of t position, something like this. This might work. And what this would do is get us the editable property attached to that position. You would just have to do this manually every time you wanted to do this, and get an editable thing, because without this, it doesn't work. And I don't know if that's clear. I don't know if that's actually good. This looks gross to me. And I'm not sure I want that, especially if we implemented our own language, for example. There's some downsides there. One, you need to learn whatever that language is, and we need to write a compiler for it, which doesn't sound fun. Luckily, we can make it pretty simple. So we could do like game objects. It's gonna auto correct me here, but just ignore all of that. Dot tagged. And I'm just making up syntax here. Tagged dot transform dot position. Something like this. I don't know if this is good. We could do actual SQL and do like selects. Again, I don't know. This makes me not. It's nice because it's short. I feel like to make this really good, we would need a lot of work though. For two reasons. One, we would need something to help with the syntax so you could learn the syntax more easily. And two, we'd need some way to extend this, because one of the advantages of being able to write these queries like this is they don't need to return nothing. In this case, we could do, I think there's like a for each or something here. So something like this. You could do like a for each t dot position plus equals vector 3 dot up, and this would move everything in the scene up 1. This is potentially possible if we do scripting using C#, and it's pretty easy because any helper functions that you add would automatically get pulled in as well, and you would just instantly have access to them. But this is hard. Maybe the best thing is to do that property of t and just do like transform position, something like this. Yeah, we need to figure it out. Anyway, most of the point of this stream is to figure this out, because this is going to take the most time, and it's going to have the biggest impact on this project, I think. If we get this right, I think it's going to be really nice and fun to use. If we get it wrong, it's not. It's just not going to be something people are going to want to use. And this is already long. in my experience, it's been sort of a hit or miss whether people use LINQ or not. And this is sort of based entirely around that concept. So maybe get component dot property of, and maybe we do something like this, or even I don't know. We could do like type of, or rather name of. This will work. Name of transform dot position. Does this compile? It does. Okay. So maybe this will work. We can add an extension method onto our list of mono behaviors or just objects in general. So a list of objects. If you do property of, it will return a property here. This means we need to change how we store things. So right now, everything is stored as an object. That object is going to change and become much more complicated. If it's a reference, it will just be a reference and it will be fine. If it is a value type, we need to do a whole bunch of things. Yeah, this is going to get complicated. Also, this is like this entire project right now is like in the scratchpad state of, does this actually work? Is this useful? So code is all over the place. Like I have just logic in my UI and this class storing all the actual information just in the main drawing component. Ignore all of that. I'll refactor it. Some things are in namespaces, some things aren't in namespaces. It's confusing and weird. That needs to change. But I actually like this property of thing. It's a little bit different. You'd need to know that it was there. But I think we have a warning that we show inside of the result component that says the results of this query were a value type and can't be modified. So you see that here. We could change this to say use property of to get properties that you'd like to edit. That might be enough to kind of a hint to kind of lead people towards what we want. Yeah, I think we'll do that. I should also note the actual execution is all fake right now. These are just like random queries that I seed it with just at the start. And then if you click run, it just deletes whatever you had there and inserts these two things. So this is the camera position of the main camera and the light from the main directional light. These are both read-only as well. So you get a prompt to change it right now if it's read-only, but it doesn't actually edit it. So that this doesn't make any change. You can see like I can click and drag to try to change the value. It doesn't actually do anything. If this works, both of these should start being editable. That's sort of what I would like to get this done to, or get this to. We'll see. This is probably going to be a complicated process because this I think is the hardest part of this entire thing. Is figuring out how to do this syntax. If we lean into extension methods, it might be enough to get us to a working thing. So maybe we'll try that. And then if it doesn't work, the fallback to the fallback is a custom language. If we can avoid that though, everything will be better. It is ideal that we don't have a custom language. If we do, this tool is not going to be as useful as I want. Without a bunch more work, because we could make it so that things were settable. I just don't want to do all that extra work because it's going to be a lot. And if we can get this working, we already have C#, and it's going to be plenty for everything that most people are going to need. So ideally, we just use that. So let's actually do something. All right. property of. Let's implement that. So I have this helper thing inside this game objects. These are extension methods that are intended to be helpful ways to get a bunch of extra things, sort of entry points for this entire program. So you could find game objects with a name, game objects that match some specific name. In this case, it does a search over all game objects and sort of does a regex to see if it contains that name. So you could find like any object that started with camera or included camera in its name, for example. So sort of a more fuzzy search than just searching for a specific thing by name. I feel like that'd be helpful. We have with tag, which is just a wrapper around Unity's existing thing. Mostly I want game objects dot to be sort of the entry point. And then maybe we even have like some alias to shrink down that game objects, like GO or something. This is really quick to kind of actually start writing your query instead of doing a bunch of boilerplate. That's the goal. With mono behavior, just finds every game object with a specific mono behavior and actually returns the game objects attached to that mono behavior. So it doesn't find it doesn't return you the component. It actually returns the game objects. All of these functions return a list of game objects. In this case, it's just one game object, but many of these return multiple. And then innumerable game objects does other things. So this gets the actual component of out of game objects. So given a list of game objects, this will find a specific component type in that game object. Yeah, let's put it in here. Public static enumerable. We're just gonna make this an object for now. This is gonna get gross. Property of. How do we want to do this? I don't know. We're going to do property of an object. Or then the string, which is going to be the thing. Let's do this. Enumerable of any object. So if you're iterating over any object, you should be able to pull out a property. We're probably going to need something for fields as well. I believe Unity mixes and matches, but most things I've seen are properties. But most other people who are implementing mono behaviors, because they use fields, we're just going to want that. I think for fields, it's easier. I don't think we need to do most of this for fields. The downside is people are going to use like a field of a vector 3, and then we have the same problem all over again. Yeah. Anyway, fun things. String property name. Right. We'll just call this objects. Turn objects select t.getType. So we're going to get the type of the thing and then get the property of the thing. This is using something called reflection. Reflection allows you to inspect types and modify or work with the actual type definitions of objects. That's sort of what we're relying on. So this is a way to get all of the functions on an object, or all of the fields on an object, or all of the methods in object supports. You can kind of use it to view information, like actual programming related information about your objects. Typically, if you can, you want to avoid it. It creates a lot of flakiness in your code, and it's really brittle. But in this case, it might be helpful. That's why we're using it. So get property of the property name. And we're going to do a whole bunch of other things to that. But that's enough for now. So what this does is this gets us a property we can get and we can set from that property. We need an object that we can actually use to store all of this. And since I think this is going to be a very large object, I'm going to create a new class for this. That's going to do a whole bunch of things because it's going to be multi-purpose. Basically, this is going to be the interface over which everything works. Because we're taking this approach, this object is going to we're going to create an interface first, which we'll just call it a property assigner. Sure. And this is going to have two things. It's going to have a get value and a set value. All right, cool. And these are going to do something like this. Types are weird. I've talked about this in, I guess I never released that video, but anyway, types are weird in this, in what we're doing. Part of the issue here is that if we are using types, like if I made this generic, for example, C# uses something called generic reification, which means that, well, here we can actually demonstrate that. So list int and list string. If you're familiar with something like Java, for example, that uses what's called type erasure, and that actually, during compile time, eliminates all of the generic things and effectively replaces them with objects. So if you actually try at runtime to test what type is this generic thing, Java is going to tell you it's just an object. That's not how C# works. C# and Java are very different in this case. It's one of the cases where they're notably different. In this case, C# is actually going to create a new type that stores this specific thing. So a list of strings is separate from a list of ints, which means it becomes very difficult to create a set of generic types that do not have a single unifying generic value. So like if I wanted to create a list of objects that's had a list or a list of lists of objects and tried to put both of these two lists into that list, this gets really complicated and hard. So we're going to just stick to objects here. I already have code in place to kind of handle the casting for us, so we should avoid any complications here. That was very long-winded, but it's kind of important, and I imagine there's going to be questions about why not use generics here. That's why. Just because it gets complicated. I actually already solved that in one of these things. Why is this thing called class 1? Anyway, here. We ran into the same problem here. So internally, everything is an iResult renderer. So all of the code that I am calling is this generic object renderer. But then if you are actually working with this code and want to create a custom renderer for your own mono behavior or type, you could use a result renderer, which is generic and only requires you to implement the generic version. And then the typing is already handled behind the scenes for you. We're going to do something similar in this thing. So let's call this property assigner. So that's our interface. This gives us a way to sort of define gets and sets that can be used. And it also allows us to create sort of a reference to property assigners that we can call. And then we want something here. Let's create a public class property assigner, which extends the property assigner. We'll see if we need to change these interfaces, but I think this should be enough. And basically, we're using get value and set value as sort of our intermediaries here, this provides a way for us to assign from these functions. And it will figure out what to actually use. The advantage here is we do not actually know what the thing is. It may be a reference. So we may have a reference to a field. It could be a property, and we may need to access that property instead. So we're going to have like a property something. I need to figure out what type that is. So we're just going to do like int.getType. Actually, we need 42.getType. Get property. And this is property info. Oh, actually, there's some cool things that are going to come out of this. We could potentially expose functions by doing this. I'm trying to think what would be a useful thing for that. Basically, because we can detect the types that are being exposed here, we could do instead of just property name, property of, for example, we could do function of, and give you a function that was anything, basically anything, and you could just enter the arguments there. This could actually lead to some fun things. But anyway, we need property info, which is going to be the property. We're going to make these nullable types. We're also going to insert some other things, so field info. And I think function info. This is weird. This is gross, but method info. There we go. All right. Let's take out method info. That's just going to be a reference for me, so I know what to do. But from here, we now have our fields and we have our properties. We should be able to actually work with this and do some fun changes here. All right, so it wants me to use a nullable annotations context. I don't really want to do that. How does this work? Like end region. This is something new in C#. Anyway, we're gonna ignore that. That shouldn't cause any issues, I don't think. It should just be a warning for now, and we can fix that later. Cool. All right. So this is what we end up getting. All of that's the same. We haven't actually changed any of the fun things. What does this extend? Member info. Okay, cool. Is that the best way to do this? Maybe. What's in a member info? Okay, so this doesn't have setters and getters. That's all we need to know. If it did, we could just use member info everywhere, but it doesn't. But we're going to use that in the constructor. Public property assigner. And that's going to accept member info. Like this. And if info is field info, then field equals the info as field info. Do I actually need this? I think. So the way as works is different than a cast. If you use info as field info as we're doing here, if it can't make that conversion, it returns null. So we should just be able to cheat a little and do something like this. I don't know if this is the safest way to do this. And there's also the concern of we just get both of them as null, and we need one of these two things to work in order for everything to be happy. But we'll see. And I think we're gonna do object here. This could be a mistake, but I think we actually want this. One of the first demonstrations I did was sort of the I don't remember. But if you pass in a class, like just a normal class into this, that's fine as it is. We don't actually need to convert that at all. And so because that's already a reference, we can just use it. We don't need to change anything. But I think that is value type. Yeah, we'll do something like this. So if all of that fun stuff, if it's a value type, then value equals info. Oh. Okay, this is this is fun. Things are getting weird, but that's okay. It should be enough to actually get us started. So let's switch. How do I want to do this? I'm digging myself massive holes by implementing this in this way. But I think it's probably a good idea. We'll see. Nobody needs to see this code, right? So we can make it gross, and then somebody else can find it by accident, and yeah. Anyway, there's everything. So if it's a value type, it just gets ignored, and that will never get set. Otherwise, if it is a reference type, value is assigned. So we have value will effectively be a reference. So we'll just call that reference. And that is actually going to point back to whatever the reference is. Otherwise, we're hoping to get a field info or a property info. If we get none of those, we're going to add an is valid public is valid. Let's do is read only. That'll be a better option. So if it's read only, that should be return reference that has value. What? I'm confused. Reference is equal to null. We'll just go with that. And field dot has it's ignoring my nulls. Okay, that's what's happening. Property. I think this is fine. Because I think these should all be references, so they can be equal to null. Just like that. So we don't actually need the nullable reference there. So we can pull that out. Is read only is just if everything is null, then it is read only. We're going to add an object of the value. Say value equals info. And we'll do that if it is a value type. So value equals info. So if it's read only, then the value is info. Get value is if is read only, return the value. Otherwise, we have a whole bunch of other things that we need to do. In this case, it's probably going to be a switch of some kind or an if, more likely. So if let's start in the order that we want to process these things in. So in this case, we want to look for a reference first. So if a reference is not null, then we have a reference to something, which means it's a reference type, and we have it without having to do reflection, which is like the best case scenario. Downside is this only is probably going to work if you are doing custom types that you've created that are non-structs. So this is probably not a very common case, because I imagine most things are going to be looking for like editing normal Unity things like positions and quaternions and colors. Quaternions are going to be weird. We're going to have to figure that out. I don't know what the editor is going to look like for that, but we'll figure it out. Anyway, if you do get this, it's just return the reference. And very, very, very simple. The other ones aren't going to be so simple. Else, if the field dot is not null, then we want to return field dot get value of our object. That's a problem. So these field infos and things only are for the object. Container. There. All right, we're using a lot of like very vague things. I don't like the names that we're going with, and the types are all over the place. Lots of objects. Very, very broad choice of objects. Anyway, there's our container. We want to get the value of the container. Wait. Oh, yeah. All right. So we already have the reference to the field. What this is saying is the field info is pointing to something. It's saying for this type, this is the field to look at. But it doesn't, the field info class does not actually know what object to look for that field in. That's why we need a container. So the container is going to be our object. So if we're passing in some transform, that transform is the container. And we want to look at the property for that is position. That's how this is going to work. It's a little bit confusing, admittedly, but that's just how it has to be. And then property. And this should be the exact same. So just get value like that. And sets and everything else should also be fairly similar. And we can pretty much copy this down here. But if it's read only, we just return. There's no, this is a no op. The object is read only. We can't change anything. Potentially throw an error, but for now we're just going to leave it and say that can't happen. I think we'll handle errors for this higher up. It shouldn't really ever get this far. This is sort of a failsafe. So if the reference is not null, then reference equals object. And that should assign it to whatever the value is we pass in. Field. How do you want to do this? Field. Set value. Object. We also need the container. And for property, same thing. Property.set value of the container to the provided value. We're gonna rename this to, what is the rename hotkey? Control R. Okay. We're gonna call this value. There we go. And that should be our fancy new property assigner. Hello code pass return a value. Got it. What do we return if none of these are true? No. Oh, that's gonna lead to a bunch of problems. We'll leave it for now. This needs tests. This very much needs tests. Otherwise, we're digging ourselves a hole, and the tests are going to get us out. I hope. We'll see. But that is our property assigner. So we need to replace our object with a property assigner now, which is in here somewhere. Where was I even defining that? LINQ command. The result is now a property assigner, like that, which is going to break a whole bunch of things, which is good. It means we can go and find that. Yeah, game objects with name main camera dot with component, get component of type transform. We actually want light dot this is getting gross, but dot property of light. Dot first. Does that work? Maybe. We'll see. No. Cannot convert from object to property assigner. This needs to be a property assigner. What? Why doesn't it exist? Did this create a namespace? It did. All right. We're just gonna pull that namespace out for now. More work to do later. But yeah, I'm generating code in 2 different places, and that is causing weird things to happen. Half of it is generated in Visual Studio and half of it from Unity, and Visual Studio and Unity generate things slightly differently. The templates they use are just not the same, and so we're getting different things. That should hopefully fix things, but it hasn't. Property assigner. Huh. What? Is this like a compiler thing, or am I missing something? I'm not sure. Either way. All right, so get property of, this needs to create the, this is gonna be gross. New property assigner of type T with the property thing. Yeah, all right. Didn't talk about too much about what this is doing, but we're creating a new property assigner with our container, which is the initial object. In this case, that would be the transform. And then we're getting that type and getting the property that we asked for. Hopefully this works. I don't know why it's saying it doesn't exist. I'm wondering if this would fix it. We're going to get a bunch of errors here, but that's fine. I'm just curious. Oh, it's still saying the namespace doesn't work. Huh. Public. Yeah, I don't know. For whatever reason, it says it doesn't exist. That's weird. In this case, this initial seed data, I'm just going to delete, because we don't need it. And that makes our code a little bit shorter, so great. Could not be found. Perfect. We're assigning back to this as well. That's not going to work either. Yeah. What's this? Couldn't be found. All right, cool. That's okay. But it's okay. This is weird. That seemed fine, but why is everything else angry? I have lost myself. Oh, that's why. This is in the wrong place. It's outside of the editor folder. Let's just bring that in for now. Reload. All right. So that should make these able to find each other. They were in different assemblies. And so it should. Yeah, there we go. All right. Property assigner's there. Somehow we don't have any errors. I'm not really sure how that happened. There we go. New errors. Perfect. .render. Bar result. And then we need to assign that back to the result. So in this case, property assigner dot get value. Wait, what am I doing? We're just going to call dot get value here. And we're probably going to want to pass it if it's read only. Dot result dot is read only, like that. So we're changing the signature here, but the intention here is that the render function should never need to know about this internal implementation detail that is doing a bunch of reflection. Because renders are actually going to be something that you can implement yourself, and you shouldn't have to touch reflection as part of that. If that happens, something horrible has happened. So to avoid that, we're going to pass in if the thing is read only, so you can handle that there. And also we're just going to pass in the value. And the thing already handles getting the value from all those different sources. So it should be handled for you. You shouldn't need to do that. The render is already typed for you as well. So it should just work. That's the goal. Because these renders are actually super simple. This is how you render an int. And so the purpose is to keep these as small as possible, because you should be able to implement these fairly quickly for yourself and just be able to use them. And if you have to deal with reflection as part of that, or even like the internal types that we're using, that doesn't make any sense. You just get an int and return an int, and that is the entire function. We shouldn't touch that. That's something that I'm actually really happy with. So we're going to leave that as much as we can. Anyway, we render this, return is read only, get value, and get the result. And then we want to do command.result.set value of the result. Cool. I just said we weren't going to touch the render. We are going to touch it a little bit. Is read only. Like that. And we'll pass that in here. Is read only. So the downside here is that I actually need to go and change a few things. All those renders that I just said we weren't going to change, I do need to change them to add this one flag. But I think this is actually valuable because if you having visibility into whether the thing is read-only or not is actually useful. You can change how you display information depending on if it's read-only or not. And there may be values where it's actually valuable to just list all the positions of all the objects in your scene, for example. That's fine, and you don't need all the editable things, and maybe you actually want it more condensed than if it was editable. So we're going to pass that up and allow you to handle it how you want. It doesn't mean all this broke. Cool. Read only. Oh, can't do read only. Is read only. We're just going to copy that into the other ones. Quick. And if this just works, if I suddenly have editable things after this, I am going to be so happy. I originally estimated this whole editable thing to be like hours and hours of work. So if this reflection shenanigans just works, I'm going to be super pleased. So if we click run, everything breaks and keeps breaking. Okay. That's odd. Specified cast is not valid. Okay, so we're getting two errors here, and you can't see either of them. What's happening is we are getting an error with the specified cast is not valid. So we can't actually cast to the type that we're asking for. The other one is a GUI issue. Because we're throwing an exception during our GUI rendering, we're not actually clearing up the stack of our GUI, and that's causing Unity to complain. But the issue is in the result render line 25, it looks like, which is in here, line 25. I don't think I need any of this. I think I can get rid of that. So we're just gonna clean this up a little bit. There we go. So is read only, and then we cast to the rendered type. The problem is the value that we're getting in is not the correct value. We are getting a invalid type. So how can we tell what that is? Settings. Actually, I don't think we need a breakpoint. My understanding is Visual Studio is smart enough to just break on exceptions. Let's see if that's true. So we start a debugging session. Enable debugging. Unity might get a little bit mad at me for this, but we will see. It has to recompile the entire project, so this might take a bit. There we go. Run this. Bunch of exceptions. Okay. It did not catch a thing. So how? There's a way. Debug. I don't know. There's some way to break on exceptions, but I don't know what it is. So we're just going to throw a breakpoint in here. and run this. There should only ever be one invocation of this anyway, because we're just looping over this one object. So what's the value here? Oh, that's why. It's not right at all. We're doing something wrong. That was showing light as the thing. Yeah, property of light, of the light. This should be color. Right? So just to make it clear what's actually going on here, if we have a light called light, what we want is we want to edit the color. We're trying to get that property. I had typed light, which 1 isn't a thing, but 2 is definitely not a color because it's not a thing to begin with. So that wasn't going to work. That was why we were getting the exception. I don't have exception rendering as a feature yet. That's later. Oh, that broke too. Dang. Specified cast is not allowed. Boolean is read-only. Okay. The other thing that I think was important is, where was it? Result render. So let's grab our exception. There it is. This value is not the color. It's not the value of the color. It is a this is the reflected type. That's not what we want to be returning. If we're doing that, things are wrong. So we need to go to the property assigner and find this get value, because we're getting something wrong. Okay. Let's invert this. So what's happening is the reflected types are a reference. They're a reference type, and so it's detecting them as a reference and just returning that as the object, which is not right. So we need to correct this, and to do that, we're just going to say if it's not one of those two things, and it is one of these, then we're good. That should work for properties, and it should avoid all the other confusion. Tests will catch this. Once we get tests, it should be fine, and those kind of issues should be avoided. We're just not there yet. Oh, it's still broken. There's no light attached to the main camera. Oh, well, okay. We can fix that. This is the problem with doing hacks. Where were we searching? Yeah. Let's just do that with mono behavior light. What type is light? It's a behavior. Let's change this. Where's my with mono behavior? Let's just do with behavior. Changing these functions as I go. They're intended to be helper functions, so if they're not being helpful, we're going to change them. Especially, nobody else is using this tool, so it's best if we keep them as small as possible and avoid extra work. In this case, with behavior should work, and that means we can get lights. So this will compile. Let's clear all those errors. Run this. All right. Now I'm going to open up the light over here. If this works, when I open this and change the value, we should be changing the color of the actual light, and we are. So this works. We now have access to our main camera's light after this query. The query is a little bit funky, just to remind people what that looks like. It looks like this. Actually, let's do var results equals there is our results. That's the sample query. And then for each of our result in our results, let's just add the command. Like this. So we still need to automatically detect what renderer to use here. But in this case, we can get all the results. In this case, we are now getting all of the objects with a light attached to them. So if I add additional lights, we should now also see those extra lights start popping up as well. So let's just do that. Let's just add a new light, add a spotlight. And so if I run this, we now get 2 lights. The header isn't right. And ideally, the header is going to be the query you ran. So you can actually see that and probably copy it back to your clipboard. So if you want to edit it and do some other things, and then you'll get both of these. We're just hacking here to kind of demonstrate things. But this gives you both the lights. So we can actually edit our spotlight here, which should be right here, and just make that red. Or we can make our directional light just white. And just go from there. And then ideally, eventually, you'll just be able to write any query you want and pull any of those things out. That's the idea for this tool. I think it's going to be really useful because this gives you a lot of useful stuff. One thing that I am thinking we might want is a bulk edit. So in this case, we get all of these results of different lights. There's a value in being able to say, I want every light in the scene to be this, or to apply certain operations to the entire thing. You can just write that in code. So we could property of color dot how do you do something? This is something I'm actually not certain on. How do you iterate over this? Is there a quick like func thing? Maybe we can add that. I'll have to look and see what the format for that is. But if you wanted to perform some function here, you could just type this in up here and just say like dot set to color dot white. Just as like a basic example. And this would assign every color property of every light in your scene to be white. That seems useful. Obviously, there's things like add, so you could add to this. That's more useful for like positions, but you get the general idea. This seems useful to me. Anyway, I'm going to keep playing with this and just see what we can do. So with behavior transform. What is transform? Component? Oh no. Okay. I need to better understand Unity's inheritance structure. So behavior is a component. And component is a Unity object. Object in Unity is weird because Unity has their own object class that is not C#'s object class. Let's make this with component. There. Maybe it makes even more sense to just use .with object. The problem with that is objects don't actually have a reference to the game object. So there's no way to actually get the game object assigned to a Unity object. That just isn't a thing. But with a component, it seems fine, so that we can bubble that up as high as we need. Let's see here. Cool. What this should allow us to do is get all of the transforms of with component transform get component. We want to get the position. And let's do the same thing for property of scale. So we're going to get the position of all the objects and the scale of every object in the scene. This needs to be a vector 3 render. Eventually, all of this, the render stuff is going to be automatically detected. We're going to have some probably other reflection thing to find every renderer defined in your scene or in your project and compile them and assign the best one for the type. I just haven't got there yet. This is all like 2 days of work at this point. And most of it has been me figuring out what I actually wanted to do. So we run this. No reference set to. Why'd we get a null reference? Is this because I reused my list? Might be. Scale isn't a thing. That's why. Transform t dot local scale. Right? Yeah. All right. Now let's try this. I'm just happy this is all working. So the curly brackets thing, I switched a few years ago. I used to have curly brackets on their own independent line. I used to think that was nice because it made it very obvious where blocks of code were. So you could tell where the indents were. Obviously tabs do the same thing. But when you are separating things with those curly brackets, it created a very distinct block of code. I started condensing it just because I feel like with longer code it's a lot easier if you condense things. And I think I changed my nope, never mind. It's still doing separate lines. But if you see my C# code nope, not here either. Never mind. I guess I do a mix. There's your answer, because that's the function I wrote, and this is one that was generated. But in Visual Studio, my settings are new lines. Really, I don't think I care one way or the other. Same thing with tabs versus spaces. There's good arguments to be made in both directions, and really, I don't really care one way or the other. Anyway, that's my very diplomatic response. But here's all the positions of everything in our scene. That is so cool. All right, and we can move things too, right? So if let's just attach this over here so we can actually see. If we rerun this now. Right. That's a thing. I didn't think this through. We don't clear our thing. Let's do command.clear. There. Much better. That's going to go away. All of this is going to go away. But just for testing, I feel like it's easier to do this. So we have our game object. That should be this one of these. These are unordered, so there's no way to actually tell where any of this stuff is. But we should be able to move one of them. There we go. So changing this changes the position of this new game object we created. This should be our camera, so we can move our camera around. And there you go. Whole bunch of fun ways to kind of change everything about your scene. There's a lot of things that still need to happen here. Obviously, this is not even close to done. It's still very much in the experimenting and figuring everything out stage. And hopefully more will happen. I think the next step is doing actual list rendering, because that doesn't happen. Right now, I'm manually taking the list. I'm taking the results and adding LINQ commands for them. This actually isn't how this should work. Instead, I should be assigning the results to this LINQ command. Is that how I want to do that? I think so. Still figuring that out. But this should actually contain an enumerable of results. So let's actually do that. Why not? So scale, we will just leave like this and just assign results there. We'll do the same thing here. Assign results. Those are unhappy, but let's make this an enumerable of property assigners. We still may run into issues here. I'll probably move this around even more. But for now, I think we want it to be a list of property assigners. The downside is if you try to access a single property, this no longer works. So you could just try to get the main camera's position. That's not possible anymore. Now you need to come up with some way to wrap that in a list. Yeah, I don't know what I think about that. But for this, I think it'll be good because we can go into our execution results. And here, where we are rendering everything. So command.expanded, if it's expanded, do this. We have our read-only messages, so you can still see the read-only warnings. If something. How do we want to do this? If for each command.result. There we go. Assigned value. All right. Naming things differently a little bit, but should be fine. And we're just going to grab the results out of this. And do result. Here. There we go. That should fix everything. And now instead of those 8 options that we have, we should just get 2. There we go. And so this green line on the left side is intended to be a quick way to see whether this worked or did not work. So it will be green if it succeeded. It will be red if it failed. So if there's an exception thrown, this is intended to turn red so you can kind of quickly see, oh, that failed. It's also a handy way to collapse this. So if you click it, it collapses the results. You can also click the scale. When it's docked, it looks like Unity has a little bit of an issue with this. So we might need some padding here. But when it's just floating, it's a lot easier. So I still need to figure all this out. I'm still learning Unity's whole UI system. But this is the entire results. I feel like this is actually relatively nice. The downside is there's no labels here. So there's no way to actually tell what this is attached to. Maybe that's something we can add. I don't think I want to attach that to the renderer. Does that make sense? So I don't want the renderer to have to render the label of the name of the game object attached to it. So we shouldn't need to change the render. But I think we do want GUI layout begin horizontal. And again, we're combining like every part of our code into this one function right now. I haven't refactored anything yet. That needs to come later. We'll get to that, but we just haven't yet. Instead, we're going to do GUI layout.label. And we are going to give it some name. What's the best way to do this? So we don't actually know what the name of this thing is yet. I want something like that. So owner is going to be the game object or thing that owns this property. I don't know if that's the best way to go about doing this, but we're going to add a property here, public string owner. Let's do that. This is a little bit gross, but I think this works. You may not know this, but you can actually assign to get only properties. It's a little bit counterintuitive, but you can actually assign to them, but only in constructors. So doing this means that we can actually assign owner a value. But if we tried to do that like down here and do owner equals foo, this doesn't work anymore. Can't be assigned to, it's read only. But it's only read only after it leaves the constructor. When you're constructing the object, you can assign to get properties all you want. So that will be fine. We need to find all the references to this. Find all references. Property center, this, we want, oh, this won't work. We're just getting the property of an object. There's no way to make this work. This is not going to return what we think, or what I was hoping it would return. That's unfortunate. Why did I run that? That didn't need to do that. Actually, hey, that's actually kind of everything we needed. We lose our fancy tables, but maybe that's helpful. I don't know if that's the best way to do this. Especially, so not everything's going to be attached. Not everything's going to be attached to a game object, right? That's how we're using this, but this could actually be used to, say, modify input controls. You could query your input controls and pull that data in here and render that as well. I don't think that would render very well. I'm gonna pull this out and think about that a little bit more and try to get a better idea of how that's going to work. But for now, I think it's fine as it is. We'll just leave that as it is. It's kind of hacky, kind of not really what we want. The problem is it leaves everything sort of hard to understand. But we'll probably be able to figure it out eventually. Maybe, I mean, no, vector 3s can't go back to what their thing is. So yeah, you'll have to figure it out. Kind of go from there. We can probably make this work somehow. The reason I'm hesitating is the way that I'm thinking about this means we more or less have to re-implement LINQ. So all the basic functions like select and things, so that you can pass along the overarching game object down the chain. And I don't want to do that. It makes everything more complicated, and the value of this entire tool is that everything is very concise. This is not clear, but I think we'll find a solution for that. But being able to actually run these queries and find all this stuff is actually the main value. Yeah, I think that's most of it. I don't know how much else we need to do. We rendered the lists. We have all of that. One thing we could do is create a result renderer picker. Is that what I want to call it? Let's add that here into the editor just quickly. We're gonna pull out the namespace again. All of this stuff is going to be namespaced eventually. To keep it out of all of your code that you're gonna have, because ideally you'd import this into your own project. This shouldn't pollute your own project. That's not good. But the result renderer selector is going to select renderers that are available and assign them to any given type. I think that's how we want to do that. And then from there, we should be able to remove, where was it? In here. So we have like, we're explicitly saying use the vector3 renderer here. I want to be able to pull that out and just say, for this result, select the correct renderer for that. Result renderer. That's wrong. Selector. This is going to have two functions, public result renderer. Type. Cool. So the first one is going to search all available renders in our current assembly. Again, we're going to use reflection for this. And then the get result renderer is going to return a specific render for that type. How this is going to work is I'm actually going to maintain a set of renderers and just return that. So we're going to create a IEnumerable of result renders. Sure. All right. Some things apparently are namespaced for whatever reason. Anyway, this is going to be our available renderers. Cool. We can't actually use an IEnumerable here. We're going to use a iList. We need to be able to edit this and add to it. So available renderers, capital R. And new list of result renders. We probably don't need to use an interface here. We're not going to ever return this list. It's never going to be visible outside of this class. I just try to stick to using interfaces here because it keeps me honest. And I only use those generic functions. And then when I need to optimize things by using a more appropriate data structure for whatever use cases I'm using, typically it's a lot easier if you aren't using those explicit functions to kind of trick everything. That's something I've found. So using an iList means that we have like add and remove, but it doesn't mean that we necessarily know that this is an array list. Maybe if we want to use a linked list, for example, we could swap this out. Or if we wanted to use some other search thing, it should be easier. Generally, it's not that big of a deal one way or the other, but that's just a pattern that I use. Get result render. We have our type. What do we want to do with this? We want to find the result renderer that matches. I don't know what that is yet. Build result renders. This is hard. We need to do assembly something. I don't know how to do this, so we're gonna ignore that for now. For each var render in the available renders. I'm going to look for explicit matches here and only do explicit matches. This is not the best way to do this for now, but it will work for now. For example, I believe I can double check this. Never mind. I was under the impression that some of these vectors or something inherited from one another. They don't. That's fine. But if there's inheritance in this, we might miss some things because we're looking for explicit references. Do we need to do that? Let's not. So, okay. I should talk a little bit more about why I'm talking about this. There's two different types, like there's a bunch of different ways we can look for types that match. We can look for just an explicit type. So if we have an integer, we can say, I expect to find something that matches an integer. And that integer has to map to another integer. We could also just look for something that is in numbers, like floats can be cast into integers. Should that work? I don't know. There's also inheritance. So if if your cat inherits from animal, if we have a renderer that supports animals and one that supports cats, but we find the one that supports animals first, how do we know not to take the animal one? We need some decision making thing here. We're going to ignore making that choice of how we find the correct renderer and just find the one that explicitly matches the supported type. It should be a little bit easier. That's what I'm trying to say. So if type is equal to our renderer, that's not how that works. I don't define this. That's good to know. Rendered type. All right, we need to create this. So let's do that. Public type rendered type. It's going to create a getter. There we go. We need to implement that now. So public type rendered type. And we want to return rendered. Does that work? I was worried about this. I think we do type of here. That should solve this. There we go. Get the type of our generic component and return that. That gets us our rendered type. Here's our selector. This works. There should be things assignable to or from here. So is assignable from, for example, type. We could do something like this to find those matches. Again, we're just looking for explicit matches. If we find it, then return the render. And that should get us a render. Otherwise, return some other thing. This will probably be some sort of error renderer eventually, but we don't have that, so we're just gonna return null. Actually, let's do that right now, because then we can go through how to create a render, because it's not too hard. Let's just extend the color one. It doesn't matter. Unknown renderer. Sure. This isn't going to be a normal renderer, now that I said we were going to do that. Rendered type is exception. Type of exception. Okay, this is kind of weird, but sure. This should never actually be used, but it is going to be a thing that will be there, I guess. Let's just make this null, because we don't ever want this to be found to match something. There will be a different exception rendering thing that we can use. This is specifically just an error thing to show an error. We don't care about the value. We don't care about its read-only. We just care about Gui Layout Label. An error has occurred and a renderer could not be found for the value of type. And we're going to do value.get type that. Okay. Some string interpolation. But basically, we're just going to print out the type like that and give you an error. And that's that. Super basic here. And we're going to return value. Sure. We have to make sure we don't actually mutate the value here, because we're actually using the type. If I returned like null, and this was not a read-only thing, we would actually assign null back to the value, and it would stop working. But this should keep it consistent. It shouldn't ever change, but we will get an error that says, hey, this didn't work. Now, here's our result render. We have our unknown render. All of that seems fine. Let's actually return a new unknown renderer. There. I guess this works. That will probably be some explicit thing. One of the advantages of doing things the way I'm doing them here is there will only ever be one render of any type in this entire thing. We're going to return the same reference to the same render every single time we need to render a vector 3, for example, or an integer. It's all the same render. It's just getting new values passed into it. And this unknown render would behave slightly differently, so we're going to just change that. New unknown render. There we go. And here we'll just return that render. Unknown render. There we go. Cool. Now I need to figure out how to do reflection. Basically what we're going to do is we're going to load in all the assemblies that are known and find anything that any type in the entire thing that extends our result render and has a type that is not null. That's what we're looking for. So I need to figure out how to do that. Find all types in let's pull this up. Oh, this doesn't actually look too hard. Okay. I was thinking we needed to actually load assemblies. I don't think we do. We should just be able to do something like app domain dot current domain dot get assemblies. What was going on? Get all the assemblies. Select all the types from that are assignable from our type. All right. So basically, we're seeing if the types we find can be assigned back to the type we're searching for. Got it. Get assemblies. Cool. Here we're looking for the assembly thing. Assembly. Oh, hold on. Why are they using S? Okay, weird. So basically what this is doing assembly and getting the types in that. So it's pulling out all of the types in a specific assembly and selecting many from that. What this should do is break that up. So typically this is going to find a list of all the types in that assembly. An assembly is like Unity or my DLL of all of the code that I've written. All of that is in assembly. This is going to return collections of different types in each of those things that we've defined. So in this case, result renderer selector is a type in my assembly. But it's going to be a set of types for each of the assemblies present. What select many is going to do is break that up. So instead of returning those lists back, it's actually going to return an individual item per list found. So if there's three types and 2 different assemblies, we're going to get a list with 6 elements containing both 3 sets. That's how this works. And then we need to find all of the types. This is going to be a set of types where the type, not that, our target type dot is assignable from type. Cool. And then we're going to just do a select here. Given the type, we need to actually instantiate the renderer. So we'll get to that in just a sec. But our target type is type of our result renderer. So we have all the types. This is the type dot instantiate get instance. I don't actually know how to initialize this. Dot construct. Create new. How does this work? C# create object from type. Activators. We need to use activators. Okay. What are those? C# activator. System.activator. Cool. All right. Activator dot create instance of type like that. Cool. That's all we need. Create instance. It returns an object. We want that to be an iResult renderer. So this is actually going to cast back. I think this supports generics, so we can just provide that cast automatically. Does this work? No. Okay. So create instance, if we gave it that, will try to create an iResult render. We don't want that. I want to cast all the created instances back to this generic type. So at this point, we now have a collection of every iResult render in any of our assemblies. Next, we want to filter out that unknown render. So dot where the render dot rendered type is not null. And we want to convert this to a list like that. Ooh, all right. And basically just assign this back to our available renders equals that. And let's just build result renders. Here we go. Typically, you don't want things that are going to throw exceptions and do weird things in your constructors. Here, I'm just going to do that because we're still figuring all this out, and this is the easiest way to trigger this. Because that's called in the instructor or constructor, we're going to make this private. So it will only be invoked once from the constructor. Then we want to jump into here. And create, that's not right, a result render selector. So there's our selector. We want this to be a new result render selector. And then from here, we want to take our selector, get result renderer of results. And I think I don't even need that. I think I can just go into here and remove that. We're gonna comment it out to begin with, but I think it can just go away entirely. And where is that render? It's used here. Let's move our result render selector over into this execution result component. There's our selector, and we just need to find the renderer to use for the value. So we already have the value, so var value equals result.getValue. There's the value we need to render. So let's get a render, so var render equals selector.getResultRender for the value that is provided. And we want type of this value. And then we just want to use the renderer here instead of anything else. And we can pass the value in where we originally had it. Value is a variable, but it's used like a type. Let's do get type. All right, we're using types way too much in this entire project, but it's a thing. So there's our types. There's that. We should now have a dynamically selected render. What are we even trying to do right now? We are rendering local scale and position. Let's swap this back out for a light of type color and see what we get. If this works, we should see renders for both color and vectors just be selected automatically. Oh, ew. All right, so we're getting a bunch of issues here. iResult renderer. Okay, so we are trying to construct iResult renderers. They don't have default constructors assigned to them. I believe that's an issue with the iResult renderer itself. So let's find that here. This giant LINQ statement that is a mess. We get the types is assignable from select, create instance, type dot is class. All right, so we're looking specifically for classes. We were probably finding interfaces and other things. We'd probably also find like abstract classes and other things that you might implement. We don't want that. We just want things that can be constructed. So just classes. This will probably still find abstract classes. We'll need to refine that more. Some tests will hopefully find out what those edge cases are. But we hopefully don't get any. We got a whole bunch more errors. Contains generic parameters is true. Oh, we also have made the mistake of having generics in our thing. So our result render, there's two types of classes here. The iResultRender, which is an interface, and the result render, which is an abstract class. Neither of those can be instantiated. We can't create either of those. So is there like a can be constructed? Custom app attributes contains generic parameters, arguments. What? Which one do we want? Is sealed, don't want those. Visible, value, meta member. Underlying system type. Nope. None of these. Okay. What's the best way to do this? Is instance of type, generic type, is import. Ideally, we want as few exceptions as possible. If we throw too many things in here, it's just going to get really confusing. And we're kind of already at that point, so avoiding as much as possible all the weird things would be great. We can't just explicitly exclude certain types because this is going to be running over code that is not just written in this library, but is written by other people as well. And they can construct things however they want. And so it needs to be resilient enough that it isn't just going to break whenever somebody starts injecting whatever they inject. What's the best way to do this? Find members, full name. All right, this is a little bit weird, but if it's a class and doesn't contain generics, maybe that might be enough to get us past this. I think there's better ways to do this that we might find. Hey, that worked. Wow. All right, it's a little slow. You can see it hiccups a little bit. I believe that's because it's doing the scan every single time we re-render this. But that will go away. This will be a one-time cost to find all these renders and figure out which ones to use. But we can auto-assign them. That's awesome. So this actually is much better than I was expecting to get to in this 2-hour segment. I wasn't expecting to get nearly this far. I'll continue streaming more and more about this, but I don't know how much of that I'll be able to. This is sort of a big thing. It took us 2 hours to get this far, and there is a lot more to do. Some of the things I have covered in previous videos, like running C# code in Unity, covered that. I think we might use the same solution unless I run into some issues. I think the Roslyn binaries are redistributable. Whatever we use has to be, because it's like the core part of this. If we can't redistribute it, then everything else kind of breaks. It also has to be something that can only run in the editor, because otherwise a whole bunch of other issues come up. But this should be enough. And I'll probably collect a series of videos especially when I'm working on like interesting things. We'll probably do that. But there's probably going to be like gaps here and there as I continue to work on this, sort of either late at night when I just don't want to stream, or when I'm like chilling out and watching a movie or something. I'll probably pull this up and work on it and get things done. But I'm still happy. We have a fully mutable set of things. That's a little slow. I wonder why that is. Oh, I bet I know what's going on. Oh, we might not be done. I think there may be some problems here. We just double check. Debug.log created. You won't be able to see this, but I think we are recreating this every single frame. That's bad. That's actually not good. Yeah. Yeah. So I was noticing there was some lag when I was changing these values. It should be immediate. You should be able to just change these just like any other inspector, and it should just change. That didn't happen. You can see like I'm dragging the mouse and it just barely, it updates twice there. What you can't see is there were 150 updates there that recreated and scanned our entire assembly for new things. That's bad. That's really bad. So in order to avoid that, how do we want to approach this? Unknown result render. Where do we create that in here? Oh, that's why. There, fixed. We'll make that a static reference for now. It might not be the best choice, but things should, yeah, much better. Hold on. I'm a little paranoid now. I didn't clear my console, so I don't actually know if that worked or not. We're just gonna add a space and recompile. I think this should work. You can tell pretty easily because it wipes out all the state, which is another thing I need to fix. But there we go. Perfect. All right. And now I can change these values and we don't get a whole bunch of broken stuff. So all this stuff can be moved around. We can do whatever, and it just works. Next steps, I think. There's a few different ways we could take this. One is create a bunch more renders. So there needs to be a default suite of renders to do different things. We have vectors and colors supported right now, and ints and floats, I think. Ints and strings. We need to support a bunch more. There needs to be a lot more support for that. Pretty much any default Unity thing should be supported, and that includes things like meshes, for example. And that is going to be hard. I don't know how I want to do that, but it would be really cool if you could query all of the, let's say, meshes in your scene, or attached to whatever, or pull out like resources or prefabs and be able to actually see what they look like from this screen. That would be really cool. I don't know how that's going to work. All the other things like editing materials, textures, things like that all need to happen. I've only done the easy ones so far. And there's some hard ones. There'll probably be videos about that, honestly, because that's useful beyond just this tool. That's useful as like, I want to create a custom editor and you want to figure out how to do that. So that'll probably come later this week as well. I think that's mostly it. I thought we were done and then we weren't quite done. But now I think we are. This is beyond where I wanted to go, and I need to step back and think a little bit more. This will end up as a VOD on YouTube as well. So if you're watching from there, hi. Also check out my Twitch, World of Zero Dev. If you're here right now, thank you so much. It's always fun to kind of hang out and chat with you. my schedule is a little bit weird this next month or so. So there'll probably be a lot more streams than typical. So if you want to come and hang out, probably more like weekdays. We'll see. It is getting into the summer, and this room gets very hot in like afternoonish period, like 90 plus degrees. So typically I've tended to hold off, but we'll see. I've found ways to get rid of fan noise and stuff from my mic, so I can hopefully record a little bit more conveniently. But yeah, if there's suggestions you have on things you want to do, definitely let me know, either in the chat or on YouTube or in the Discord. Discord's probably a good place to talk about this, especially if you have ideas about how to do how you want things like this to work. I don't know. I'll say this now. I don't know how distribution of this will work. I don't think it's going to be free, but I don't know. That's something that I still need to figure out, and I haven't really gotten that far. It doesn't work yet, so it seems a little bit premature. But I don't. If this was finally released, I don't think it would be free. Some notes on that. With tools, there's always support that needs to go into them. Either things stop working or they need to be maintained for a new version. And for a free thing, that generally doesn't seem like it could happen. If it was something that I wanted to continue supporting, it would be something that I would need to at least get something back for my time. And so that's something I'm still working on. We will figure that out in the near future. But anyway, that is where this is right now. Anyway, thanks so much for tuning in. I'm going to end it now. And hope you all have a great afternoon, morning, or whatever time it is where you are. So thanks so much. And I will see you tomorrow or whenever the next stream is. So until then, see you, internet.